Welcome to the Plate Tectonics review on Lt2. And the big thing with this review, or this part of the test anyway, this learning target, is you really need to know about Wagner and how he came about creating the continental drift theory. So you have to understand the progression of the theory. So remember this map that we looked at? Can you name all the different creatures on here? And some of these will be on a test. This is not going to be on a test, but a couple of these will be. Let me move these around. You've got the Mesosaurus and you got the Glossopteris. So can you tell me these? And you're going to find them later on in the review as well. But if you remember, the Mesosaurus was a reptile, and it was a freshwater reptile. And when they found it on both sides of the Atlantic Ocean, scientists couldn't really explain why, because if it was a freshwater reptile, how could it go through the salt water to get on both sides of South America and Africa? Well, maybe at one point in time, South America and Africa were connected. And when you look at the Glossopteris, this is a fern fossil. And it's actually found on all the southern continents here. And again, scientists were puzzled as to why you were able to find it on all of them, especially when you have these large expanses of oceans. Well, maybe at one point in time, a lot of the continents were together. And this is this is a theory that Wagner came up with. He came up with the continental drift theory. So let's look at some of that evidence that we have here. So what I would suggest you do is I suggest you pause the video and just see if you can answer these before I go through it. So if you pause it now, and then I'm going to start up right now. So as soon as you're done, just unpause it. So the fern fossil is found in Africa. So we just talked about the fern fossil. It's Glossopteris. Mountains similar to those in Greenland and Western Europe. It's actually the Appalachian Mountains, and it's kind of neat when you look at a map of Pangaea and you see where these mountain chains actually line up. And underwater mountain range is your mid-ocean ridge. Scientists who suggested theory of continental drift is Wagner. And scientists who suggested the theory of seafloor spreading is Harry Hess. Place where the seafloor is forced down into the mantle is your subduction zone. And then fossils found in South America and Africa, reptile fossil, that's your Mesosaurus. Now, I put both Wagner and Harry Hess on the slide, and they're going to be on another slide in a different review, just because you need to keep these two straight. What I found in looking at the Schoology and the quizzes that we took is that people are still getting these two guys mixed up. So here's a few questions that we can go over. Just let me find my pen. And if you want to hit pause quick, or tell you what, just see if you can beat me answering this. Plates are composed of the what? If you said the lithosphere and the asthenosphere, is that what you said? Well, if you said that, you're actually wrong. Okay, it's actually the crust and the upper part of the mantle. So make sure you don't skip through this too fast and just say, oh, that's what Mr. Rattoon said. No, no. The youngest material in the ocean floor is found in where? Did you say the trenches? Did you say the basins? No, it's the ridges. It's the mid-ocean ridges. Because remember, the convection currents get things moving up and away. So those plates are moving away from the middle, from these trenches. Or I'm sorry, from these ridges. Now the plates move apart so if it's moving apart, well, think about it. Converge. If things converge, are they moving apart or coming together? Diverge. If things diverge, divide, you're breaking apart. So it's divergent. So here's one of the short answer questions for this part of the test, part 2. There's two of them. They're actually both right here. So question number 1, why wouldn't the fossil of an ocean fish found on 2 different continents be good evidence of continental drift? Well, think about it. If you have South America and you have Africa over here, okay, if you had a fish and that fish was swimming and that fish was swimming across the ocean this way, would that really be good evidence? No. So when they talk about this question, I have to point out the fact that ocean fish can actually swim across the ocean. So if you found those fossils, that would, on both sides of the continent, that would really not be that surprising because the fish can move back and forth. Okay, now, was Wegener's theory of continental drift widely accepted by other scientists? This is the other question. And we went over this in great deal. We talked about it quite a bit when we did Puzzling Pangaea. And we actually reviewed some of these notes. But he was not widely accepted for several reasons, one of which was the big thing is he could not explain the driving mechanism. Yes, this idea that continental drift was good, but yet he couldn't explain how the continent's moving. And like we've read and like I told you, Wegener really didn't think that was his problem. He came up with the idea, he had all the evidence to support it, and he basically told the other geologists, you figure it out. I came up with everything else. One of the other problems is he was a meteorologist. He actually had his doctorate in astronomy. He was a meteorologist. He was only an amateur geologist. So a lot of the professional geologists, people who had the degrees in geology, didn't buy into him because they thought, hey, you know, you're not even a geologist, a true geologist. Get your head out of the clouds, Alfie. So that was against him. People didn't really believe that the large land masses could move. And you put yourself in their shoes. If you were looking out the windows, or just look out your house window, look out the windows in school, you can watch all day. You don't see the plates moving. Unless you had an earthquake, you would never see the plates moving because they move so slow. Plus, you're on top of the plates, so you're not going to see them moving because you're moving along with them. So people just didn't believe it because of that. And a lot of the evidence that would later come later in history to support Wegener and his theory, they were discovered later on in the 60s, in the 70s. So Wegener, if he would have been born 30 years later, 40 years later, and went along the same progression, his theory would have been accepted pretty quickly because we actually had the technology to help support his theory. So this is the review for Lt2. If you have any questions, any concerns that I'll remember, stop in, ask me. I'd be happy to go over anything that you want with you. So good luck on the test and have a nice night or have a nice day or have a nice weekend wherever you're watching it, whenever you're watching it. And we'll see you in class. Bye.